Hello everyone, my name is Daniel Pineda. I am a chemistry major at Ozone campus, and I will be explaining a little bit more about the ozone layer and free radicals. The first thing that I would like to mention is where the ozone layer is located and the importance that it has. So, in our atmosphere, it is located in the stratosphere, which is the second highest level coming from the Earth to this space. It's really close to the Earth in comparison to the other layers, and it is mainly made of oxygen, oxygen and ozone. Oxygen molecules are affected by light, ultraviolet light coming from the sun, and they're converted into oxygen atoms. These atoms react with another oxygen molecule to form ozone. Then ozone also reacts with light to form an oxygen molecule and loses an atom of oxygen, which reacts with ozone, which is really unstable, and creates two oxygen molecules. So this whole chemistry and this whole reaction here takes place just because of one reason. The ultraviolet light coming from the sun, it's too powerful for us to handle, as plants might burn out, species such as humans can't handle the level of radiation, and their skins, our skins have not evolved to that level of light. Therefore, the ozone layer provides a protective coat per se to human beings and to plenty of species in Earth. As depletion or destruction happens, not only because of this reaction, which is normally per se in equilibrium with one another, but for compounds that we have added to the atmospheres, and I will explain that in a second. So it is important to take care of the ozone layer, and it is important to know about the effect that it has on us as a species. So as I said, the CFCs and or carbon fluorine chloride compounds are a main contributor to the depletion of ozone in the ozone layer. So what are CFCs? They're normally metals with halogens, specifically fluorine and chloride, attached to them. A lot of them are metals, and they could also be longer chains, but they form free radical reactions. I will explain that in a second. They're normally used as refrigerants, such as for fridges, as shown in the picture, or refrigerants of air conditioning cars and air conditioning systems that are also used for solvents. This application is mostly for factories. However, it can also be used in daily lives, in your daily life. Foams, aerosol, we know them, and others is a lot of factory use of CSCs to lower temperature of compounds while working on bigger reactions. So the mechanism the CFCs have and why they're detrimental to the atmosphere. So the first thing that I would like to mention is, as you can see in the picture to the right, um, this is the South Pole. As you can see, in 1979, we already had a lot of depletion. The levels were a little bit lower than their surroundings, and this was the place where there was the most ice. And because it was located in the South Pole, more light was coming into that place. And as time passes from 1979 to 1986 to 96, we can see that the depletion of ozone is getting worse and worse by the year. And this leads to a lot of sea level rise. Why? Because if you have less ozone, more energy coming from the sun is coming into the earth. This energy actually melts our south pole faster, which increases the amount of water that we have on the sea, on the oceans. So it rises. This rise has an effect on both us as humans, and it also affects how we understand geography. And the bigger thing is climate change. Sea level rise has been proven to actually be really detrimental to the overall picture of climate change, and because more energy and more heat is coming up, it also has an effect on the greenhouse effect. Energy comes into the system and it can't really go out because of how we understand Earth. So yes, having the ozone layer being depleted, it's never good. So here you can see the mechanism that it follows. As you can see, you have a free radical reaction that we have studied previously. The carbon and the chlorine molecule break apart by the effect on light when they go into the stratosphere. You have a radical of carbon, a radical of chlorine, and they go into a lot of more reactions, into the chain reactions that consume a lot of oxygen and consume a lot of different compounds, especially ozone, which is depleting the layer. We understand that these things are not okay and they're detrimental to the environment. So a lot of bans and a lot of restrictions have been placed on these. They were discovered in the 1920s, and because we didn't have an understanding of how they properly worked, we used them without any restriction for a couple of years. which actually came up to be really detrimental by the 1980s when we already understood how they worked and the effect that they had on the atmosphere. Predictions were being made to that day that even though if we completely stop production of CFCs, we will still see the effect for the next couple of decades. There were a lot of international efforts towards stopping CFCs. A lot of countries got together and either banned them, suspend them, make them convert into some other compound that was less detrimental to the environment. However, a lot of these efforts actually were in vain because they were a major part of the economy. They couldn't be just taken out from day to night. A lot of these companies still use CFCs today, and their bans still have time 10, 20 years to stop using them. Also, even though there is a studies that the ozone layer might be healing because CFC consumption has gone down, predictions also show that in the 2030s and the 2040s there might be a peak or a constant increase of CFC uses based on how we're doing to today. So that's not good. That's something that we have to go forward. A lot of legislations, a lot of climate activists have been working towards a cleaner future. So just to conclude, I would like to say that hopefully you obtain a better understanding of how the ozone layer works, the importance that it has, and how it is important to advocate for a cleaner future and for companies to be more ethical towards the environment, which is a big deal in environmental science. Thank you very much.